Well, good morning, good afternoon, good evening, depending on where you're sitting. My name is Tony Peterle. Thank you for joining our webinar on building FM broadcast operation. The thriving part is up to you. So thank you for coming aboard. We've got quite a few online already. We're going to chat for just a couple of seconds here and talk about what's coming up before we get into it. Again, thanks for BSW for being a partner with us on this, and thanks to the whole marketing and the team in France for A, building such amazing products, and B, allowing me the freedom to do research and get into stuff where I can learn and share and help other people's lives. Again, my name is Tony Peterle, broadcast engineer for many, many years, airborne traffic pilot for many years, and for the last 20 years, I've been working with Worldcast Systems as a support personnel, application engineer, and currently I'm on a freelance contract basis with them. Joining me is Brian Walker from Broadcast Supply Worldwide. Brian's a relatively new member to the BSW team, but he's got about 20 years of broadcast engineering experience behind him. Hi, Brian.
Hi there. How you doing?
I'm doing well. Looking forward to help bringing some people along here today in our webinar. I appreciate you and BSW helping out with us.
We're excited about what we're going to talk about today.
Yeah. BSW, if you didn't know, is one of our preferred providers of our Ecreso transmitters and all the other great products from APT and Automat and the other wonderful Worldcast Systems brands. So a bit about Worldcast Systems for those who may not be familiar with us. Various parts of our company we've grown by acquisition over the decades. The core part of our company started in the early 80s as a broadcast monitoring service. We are known for our RDS encoders. And we're kind of the first fully featured RDS encoder to show up in the US with the FMB80. We were also fortunate enough to be very early on the market with an effective monitor for FM and AM IBOC hybrid transmissions with the Golden Eagle HD. So we've been building products. Our transmitter wing, Ecreso, has been building solid-state FM transmitters since 1956. So they're the longest lived leg of our company. APT products out of Belfast, Northern Ireland, of course, known for their codecs and other audio transport devices, and Automat for monitoring and control, RDS encoders, and field measurement devices. So we've been at this for a long time and have been in the U.S. for a long time as well. That's the backup button. That's the forward one. So we're based out of Bordeaux, France. Lovely place. If you ever have a chance to visit it, please go. It's great. We do about 14 million euros a year in sales, 65 employees. Almost half of our employees are R&D staff. So we're innovating. We're constantly listening to our customers, advancing our products, trying to find better ways to help broadcasters around the world. Since the early 2000s, we've had a U.S. presence. I joined the U.S. office in Miami in 2005. Our office there is currently a staff of 5. Liz, if you've ever had any interactions with her, she's the glue that holds everything together. Julian Gomez in support, Cyrus Weeble on our Kibio monitoring software side, myself, Tony Peterle, and Carolina Delgado, who's our sales manager now for the U.S. So since 2005, we've done, since I got there anyway, we've done on-site repairs and support and pre-sales and post-sales installations and given presentations and demos and stuff all over the Americas, North, Central, and South. BSW has been in business since 1973. We are collaborating with our business development, sales, and marketing, have been for a long time. And as I mentioned, they are a dealer of choice for the Worldcast Systems products. So let's dive in. Building a radio station. Well, how do you do that? Well, first you get your Tinker Toys. No, first thing you have to have is a dream. You've got to define, you've got to create the project. You've got to have a concept of how a radio station can serve the community and or make you money. They don't always go together, right? Because with LPFMs and non-commercials, there's no advertising, and so you find your operating expenses and your budgets elsewhere. But the first thing you have to do is start with an idea. It's like, okay, I'm going to do a radio station here. This is the market I hope to serve. Here's my budget and when I want to be on the air. You've got to find an engineer, broadcast engineer, can help you do site surveys, and determine where the best location is for your transmitter, and the power levels and all that kind of stuff. Then you have kind of an idea of what you want. You go to the FCC and you ask for a license. A lot of different kinds of licenses. We'll be talking a little bit specifically about the LPFM licenses later on. That's a very specific subset of license for a non-commercial, small local community station. It's got some interesting exemptions to some of the rules and the ability to maybe put a station on the air at a lower cost. So once you request the license and you have the license, then you start building your station. So you define the equipment that you want to buy. You've got to schedule your installation, mounting the antennas, testing to make sure that everything performs the way it was predicted to perform when you applied for the license, and then you're off to the races. So once that license is granted, once you talk to the FCC and you say, I want to get a license. Once they say, yep, here's your license, here's your construction permit. That's the next thing they give you is a construction permit. Once that construction permit is approved, you've got 3 years, 36 months to get something on the air. That seems like a very long amount of time, but sometimes it's difficult to arrange funding. There's sometimes delivery delays and equipments, and sometimes it's hard to find a tower crew if you've got an antenna that has to go up on a tower, but the FCC gives you 36 months. You can extend that. It's a pretty easy process to extend that delay, that deadline, but it's best to have your plans in place even really before the license is granted. Brian, you have anything to add to that?
Budget.
Yeah. And
boy, it's the one thing that'll kill you. And you have to budget clear down to tower rental and tower crews and space rental in the transmitter shack. And if you think that you're going to be broadcasting from the top of the Empire State Building, bring extra budget.
Yeah, absolutely. And Brian's right. There is a lot that goes in. He's just talking about the transmitter side end. So if you talk about the whole station, you've got so many different minuscule pieces that go into the building the studio. It can be very simple and relatively inexpensive, but it can get out of hand quickly. A lot of broadcasters, especially new broadcasters, don't think about things like EAS requirements. That's the emergency alert system. That's required to have some. That is a piece of equipment that has to be part of every broadcast station in the U.S. So sometimes people don't think about that, or they think about buying a console, studio console, a mixer, but they don't think about buying the furniture that's going to support that properly and give you access to all the inputs and outputs and whatnot that you're going to need. So there's a lot of details, and we've got a section coming up where we're going to talk about the common mistakes. So basically, here there are 4 different chunks really to building a broadcast FM station. Produce end, that's the studio side, microphones, mixers, audio sources, record, edit software, EAS. We did mention the EAS device there, maybe some sound processor, automation system to play back music. Once that signal is created, that's what your station is going to sound like. Then you have to get that signal from the studio to the transmitter site, commonly called as STL, Studio Transmitter Link. There are many different ways to accomplish that as well. Traditionally, there have been kind of a microwave or radio type transmitter and receiver pairs that would transmit that audio signal to the transmitter site. It's been done by satellite, been done by microwave. Most of that transport these days is going on via IP. They digitize the audio or the composite signal, which is the whole of the FM signal group together. They digitize that and they transport it across an IP link of some kind. So we're going to talk a little bit about IP codecs and the different ways you can use that. On the transmission end, everybody, of course, thinks about the transmitter and the antenna, but they think about the feed line that's going to connect the transmitter to the antenna. That is not only a cost factor, but it can also affect the size of the transmitter that you need to buy to achieve the signal that you want to get out of the antenna. RDS encoders, sound processors possibly at the transmitter sites as well, and your energy systems, uninterruptible power system, some kind of a backup. Some sites need a power conditioner because the voltage varies so much and there's so much noise on the power coming into the site that it can affect the signal. And then you also want to think about monitoring. Typically, the transmitter site is not co-located with the studio side. And if that's the case, then you need not only to get your audio signal out there, but you also have to be able to look into that site remotely and see what's going on. Make sure your transmitter is on the air at the correct power. You might have some other equipment up at the site that you want to monitor and control. So that's another factor to consider when you are putting your whole site, your whole station together. All right. So Brian and I at our respective companies have been around this business for a long time, and we see a lot of mistakes. Some of them are really, 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 really common. And so we're going to talk a little bit about those common mistakes. As Brian mentioned earlier, budgeting. You got to think about budgeting at so many different levels, every step along the way. And we're going to talk about some specific mistakes here. Brian, you had sorry, you looked like you were about to say something.
No.
Okay, sorry. All right, so one of the most common mistakes is underestimating the total cost of ownership. So we're talking specifically about transmitters here. And everybody thinks, okay, well, here's a transmitter. It costs 80 shekels. And it's like, all right, well, here's another transmitter that only costs me 55 shekels. Well, that purchase price is only a small part of the total cost of the transmitter. The big ticket on the transmitter is how efficient is it with the energy, because you got to pay for every kilowatt that comes out of that transmitter, and so the efficiency of the transmitter and how it uses that energy is going to have a big impact over the total lifespan of the transmitter. A transmitter is typically expected to last at least 10 years. Some go 20 years or more, and so over the lifespan of the transmitter, if you buy that less expensive one for 55 shekels, but it costs you an extra 20 shekels a year in energy costs because it's an old inefficient design, you're going to more than blow through the cost differential before you and the other thing is the less expensive transmitter may not last the full 10 or 20 years. So it's something to consider. It's like you want to buy high efficiency devices, you want to buy from reputable companies that have been in the business a long time, because it's the operating costs are a big piece of the total cost of ownership of the transmitter. And so that's one of the primary mistakes we see people make is looking just at the sticker price and not considering the total cost. Don't ignore the fact that technology is always evolving. More software in the product, less hardware-based solutions, using digital signal processors instead of a specific chipset. So look for equipment that offers that sort of hardware or that software-based flexibility and upgrade options so that you can add in functions later on. A good example of that is there's a new standard for RDS. RDS is the text display that comes up on the radio's analog FM broadcasts. There's a new RDS standard, RDS2. The standard has been accepted. There aren't any receivers, consumer receivers on the market yet for RDS2, but our latest line of RDS encoders has the hardware and is ready to go and broadcast that RDS2 signal with a software upgrade down the line. So that kind of option, think about that kind of flexibility as you move along. Also not a great idea to buy a transmitter or another piece of equipment that's near the end of its design life, because companies are always upgrading, and they're not going to be able to support the old equipment because often the components themselves that went into making those pieces of equipment go obsolete and are not obtainable after 10 or 15 years. So purchasing a product that's new enough to be cutting edge, old enough to have been tested thoroughly, so that the bugs are shaken out of it, but it's like you want to get something early on in the life cycle rather than buying something that's already close to the point where it can't be supported anymore. Don't underestimate delivery troubles. Of course, some of the smaller items you can just hand carry. It's not a problem. Transmitters up to 2 or 3 kilowatts, single box, couple of guys can port it through the door, no problem. A lot of the transmitters, the larger transmitters, come in big, huge packing crates, and big, huge packing crates need big, huge doorways. And so if you get up there and you find that the door is not suitable, it means you got to disassemble, unpack everything out in the yard and take it in. And if it's raining, that's a mess. So, run a tape measure over it, look at the size of the delivery crate, and make sure that you're going to be able to get the thing to where it needs to be. make sure that you've got some professional eyes on your installation. There's a group called the Society of Broadcast Engineers. They are a vast network of broadcast engineering professionals all over the country. You can reach out to a local chapter. You can look for contract engineers on the SPE website. Find somebody who is knowledgeable enough to come out and at least glance over your operation and make sure you've got all the major pieces in the right places and can help you answer any questions and even direct the installation. That can really help you avoid a lot of issues on down the line. Grounding and lightning protection. Cannot put too big an exclamation point on this one. Radio antennas tend to be on high places, on metal towers, and they have metal cables connecting them to the transmitter, which often is the most expensive piece of equipment at the site. And so if you don't give the lightning multiple options for easier paths to ground, it will happily walk right back in through your transmitter. It can come in through the power lines, the utility lines coming in. So we're not going to go into it, but obviously you can burn things up, you can lose your equipment, you can damage other equipment at the site, even if it's not yours. But it's really important to ground your systems well. There are a lot of resources online. The SPE website is going to be one of those. There are lots of videos and white papers and everything else about grounding techniques. Please read them, use them. Get a handle on your grounding and make sure you've got that done, or you could lose a lot of very expensive equipment.
Definitely.
Yes.
Definitely. I mean,
well, speaking, it wasn't my site, but I have seen, and it's not pretty.
No, it's not. And I mean, a direct lightning hit is 30 million volts at 30,000 amps. Do the math.
That's enough to melt metal.
Yes, it is. And, no matter how good they design the transmitter, it's just not going to survive a direct hit.
Nope.
So if there's anything you can do to avoid that direct hit, invest early on that.
Yeah. And it's the description, the best description I've gotten, kind of thumbnail description is you want to give, it's like somebody at the top of the tower is turning on a fire hose. And that fire hose is connected to a pipe that goes right into your transmitter. Well, you want to make sure that water has plenty of options to leak out elsewhere or go out into the ground and just, stay out of the building.
And even not a direct hit, indirect, can really mess with transistors.
Mm-hmm.
And, so that's another thing is having a spares kit on the shelf at the transmitter site.
Absolutely. Another thing. Go ahead.
You have some spare final transistors.
Right. Right. And have you studied the technique to install those transistors? Because there's sometimes if you put too much heatsink cream, it's worse than none at all. And so it's having some spare transmitters and having again, when you're back at your consideration of the expenses, the cost of buying the transmitter, think about how serviceable that transmitter is. The most common things that are going to go out in a modern solid state transmitter would be the MOSFET, the transistor that produces the RF, the power supply, or a cooling fan. And so, think about having some spares of those on the shelf and think about looking for transmitters that make replacing those things a relatively simple task.
And one of the best transmitter cleaning tools you can invest in is a little tiny $60 air compressor from Harbor Freight.
Mm-hmm.
And just blow the dirt out of your transmitter. I mean, This is a perfect picture right here. I feel really sorry for those two transmitters.
Believe it or not, I've seen worse. I couldn't find it.
So have I, but I still feel sorry for those two transmitters.
True. I have two pictures somewhere in my archives. One of a transmitter is actually one of the old Crown transmitters that had been in operation in the top of a flour mill for many, many years and was just about it looked like a loaf of bread that hadn't been baked yet. And the other one was a transmitter that was installed on a site out in Colorado and the roof caved in. And so the whole rack with the transmitter was about half buried in snow. Transmitter kept working, but that's not exactly the kind of environment you're trying to provide. So, think
On
about
the
temperature.
upside, the transmitter was nice and cool.
Oh yeah, certainly it was. A little wet too. So you want to think about temperature, of course, at the site, dust, the stability of the electrical supply. The cooler and the more stable everything is, the operating environment at the site, then the longer your transmitter is going to last. Make sure that your cybersecurity is on point. There have been many examples and stories about broadcast equipment of one type or another being hacked because it was put on a public internet address and they didn't change the default username and password. Duh. That's so basic. If you want to see what's going on, you can go to a site called Shodan, and you type in the name of a piece of equipment, something that would appear on the home page of a piece of equipment, and it will pop up hundreds of examples of that piece of equipment that are showing up on public IP addresses. So there's, again, more to cybersecurity than we can get into here, but at the minimum, you've got to do port translation. You've got to change the username and password. Try not to expose any of the equipment to public internet connections. A VPN, what they call a virtual private network. So you've got a private sealed link between your studio site and your transmitter site. That's the best because that really prevents a lot of the hackers from getting access. Don't neglect the value of control and monitoring. Because you can monitor temperatures, you can have remote cameras up at the site. There's all kinds of ways that you can monitor. A lot of the equipment has built-in web interfaces. We'll see an example of a transmitter web interface here in a little bit. But have a way to have some eyes on either just monitoring temperatures and humidities and things like that, power inputs and outputs. Remote monitoring can help you catch the small problems before they become big problems. Do not violate the FCC rules. They're the ones that gave you the license. They can take it away. So there's a whole lot of FCC rules. You'll learn more about that as you go through the license application process if you haven't already. But as far as ongoing operating regulations, you got to make sure that your transmitter is on frequency. Have to make sure the transmitter is operating between 90 and 105% of the licensed power. You've got modulation limitations, interference with neighboring systems, intermodulation. There's going to be some filtering you maybe need to do, but that's stuff, again, have somebody who has some broadcast experience help you through these things. There are a couple of rules that don't apply to the LPFM stations. That's, again, that specific class of license for the small community stations. But other stations have to adhere to political advertising regulations and maintain a public file, which contains the license and a whole bunch of other information. If you're non-commercial, that's great. You need to know what the difference is between an underwriting announcement and an advertisement. Because you can cross the line there. So basically follow the rules, keep your license. That's a good thing. So what about this LPFM we were talking about? So with an LPFM license, again, it's a specific license. It's designed for community broadcast to serve an audience that is not otherwise served by other broadcast stations. So it's a very low power, 100 watts. So it's got a range of, well, depending on where the antenna is, can have a range of 2 to 20 miles. The licensees, everybody who's on the board, member or on the board of that LPFM, whether it's 1 or 5 or 50, 75% or more have to live within 20 miles of the city to which the station is licensed. Maximum power is 100 watts, effective radiated power at 30 meters, height above average terrain. That does not mean a 100-watt transmitter is the correct choice necessarily. So the effective radiated power is this measure of the signal actually coming out of the antenna. And that's a result of several factors, including the design of the antenna and the feed line between the transmitter and the antenna. So if the antenna is higher than 30 meters height above average terrain, then your licensed ERP will be less. For LPFM stations only, the transmitter has to have a special FCC certification, have been tested by an independent lab. The station has to be on the air at least 5 hours a day, 6 days a week. can't go off the air for more than 30 days without special permission from the FCC. And even an LPFM station has to participate in the EAS system. They need only have a decoder. Larger stations have to have an EAS encoder as well, so they can rebroadcast the EAS information. All right, RF pathway and power. This is Brian's territory. We do the transmitters, but as far as the feed lines and the antennas and stuff, he's got the handle on it. Brian?
Wow. Who has a real handle on this? Let's start up at the antennas. Biggest mistake that a lot of people make is, oh, I'm going to save some money and I'll just get a vertically polarized antenna, or I'll get a horizontally polarized antenna. And that's just a mistake to begin with, because you really need a circular polarized antenna so that you can hit those receive antennas that are laying sideways and the receive antennas that are vertical. And there are also some receive antennas that are at a 45-degree angle. And so you want to be able to hit all of those. And you also need to consider whether you're going to have an omnidirectional pattern, which your signal goes in all directions around the tower, or do you need a cardioid pattern? Do you need to be somewhat directional to protect another station? Your consulting engineer is going to be able to advise you on that. My biggest recommendation is do not put in a single bay antenna, because with a single bay antenna, you're sending the same amount of energy out from around the tower as you are above and below the tower. And there's no point in sending your signal straight up and straight down, because there's nobody there. You want to be, you want to be sending as much energy out around the tower as possible. So if you have a 100-watt ERP, a two bay antenna on the tower can give you that 100 watts of ERP with about a 100-watt input from the transmitter. It's pretty close there. Good rule of thumb. Coax feed line. We're kind of working back towards the transmitter shack here. This one is really important. You need to hire a good tower crew that knows what they're doing for this part. Okay, because they're going to be attaching the coax to the antenna, and they need to seal that because you're way up in the air and you don't want to climb up the tower in the middle of January just to replace the sealing tape on the connection. So that needs to be done correctly. Also, the coax needs to be attached to the tower X number of feet. Okay, 1/2-inch line, you can get away at 10 feet. You get up to 1.5-inch line, and it's got to be about every 3 feet that you need to put in a hanger. So those are important. Also, the grounding kits. You need a grounding kit up at the top of the feed line next to the antenna, and you need a grounding kit inside the transmitter shack, going straight, as close as possible to the ground strap in the transmitter shack. So you need to ground both ends of the coax cable. Just because you measured your coax cable to be 100 feet long, don't buy 100 feet. Buy 120, buy 130 feet, because coax stretchers are really, really expensive. So you don't want to have to try to stretch that poor coax any further than it has to go. Know what connectors you're going to need. And most, like at BSW, tell us what connectors you need, and we can have them installed for you before the coax even ships. So your coax line shows up and it's got the correct connector to go to the antenna and the correct connector to go to the transmitter, and we can handle that for you. It ranges anywhere between $40 and $80 to have a connector installed. Well worth the price. Next slide. Feed line. We've kind of hit on the feed line. Hoist grips. This is one that a lot of people miss, and then they can't figure out, how am I going to get my transmission line up the tower? There's hanger kits hardware kits that you have to buy, talk to us. We can, we deal with this daily almost. So we know all the parts and pieces you need. And it's not something that we're trying to just sell you more stuff. It's stuff that you legitimately need. And the hoist grip is a really important piece because that's the thing that helps you get the coax up the tower without damaging the coax. Here is not the place to value engineer the feed line. Don't try to cut any corners here. Um, a good high quality coax, properly installed, will last about 20 years, which is about as long as your antenna is going to last. And if you're looking at replacing your antenna, you should probably be looking at replacing your feed line also, because it's been out there in the same weather that the antenna's been just as long as the antenna's been there. So if you're already sending a tower crew up to replace the antenna, the additional cost of them replacing the feed line is pretty minimal. And again, those of us at BSW, we can help you pick the right size feed line. We can, we can do all the math for figuring out how much power is going in and what size of coax to use. Antennas come with a lot of variables that have to be worked out. Polarization, directional or omni, as I mentioned a little bit earlier. How many bays? If you're renting tower space, each bay is going to can cost a whole bunch of money. So maybe you do have to go back to a single bay just because of the amount of money that the tower owner is requesting that you pay for space rent. If the tower is already crowded and already pretty close to its maximum loading, the tower owner is going to ask you to pay dearly to put that in, to put a single bay antenna on their tower. You might want to look for another tower, or you might want to look for another way to mount the antenna. Again, don't value engineer. It's this is something that it's in the air and it's expensive to get to. So don't cut corners here. Also, a lot of tower owners are going to say, these are my approved tower crews. Please respect them. They're the ones who are taking the liability of having people climb their tower. And so, your cousin who likes to climb rock faces out in the middle of Central Oregon, he's not the guy to climb the tower. Sorry about that. Work with your consulting engineer, the tower crew, and also BSW to get all those variables handled. We can help you figure it out. And I think it's back to Tony.
Yeah, we're going to talk a little bit in some more detail about the Ecreso transmitter line. As I said, we've been building solid-state FM transmitters since 1956. Have had great success. We came into the U.S. Originally in a partnership with Crown Broadcast, the Crown E-Series transmitters, and simultaneously we started selling them under the Ecreso brand as well. Now it's just Ecreso in the U.S., and our new AIO transmitter series has won multiple awards. It's got some outstanding features. So efficient is the main thing. Our guys have all been about efficiency. Transmitter design team has been about efficiency since the 1950s. We have all of the great features, MPX over AES direct into the transmitter, built-in RDS encoder. We'll get into some of that. Lowest energy consumption, up to 76% efficiency. That's from power input to RF output. Some publicity includes a figure just for the MOSFET efficiency, which is well over 76%. But what you're concerned about is how much power do I have to put into this thing to get my recommended allotted amount of power out. And so 76% is a pretty good figure for the industry. Very redundant. These two of the 5 and the 10 kilowatt transmitters you see on the screen here are both dual drive. And statistically, they provide better uptime than a main and a backup transmitter with a transfer switch. So they're very solid. We call it as solid as 1 + 1. A lot of built-in features, low energy consumption, the AIO series, the nice compact transmitters. We go up to 1 kilowatt in that. Well, actually, we go up to 3 kilowatts in a rack mount form factor. A lot of built-in features, very solid design. Our latest AIO, the AIO series, is available in 100, 300, 600, and 1 kilowatt power levels. And the nice orange thing with the FCC logo in says, yes, the 100 and 300 watt AIO series are FCC certified for LPFM licensees. So it's good to go. And speaking of going, let's go have a look at one here. So this is the home screen. Oh, it's not the home screen. Let's go to the home screen. Here's the home screen of an AIO series transmitter. First thing you see when you log in is the synoptic, which immediately at a glance tells you everything, what's going on, tells you what your forward power is, reflected power, modulation level, where's your audio source, audio levels, the whole shooting match there. You can get more detail on any of these. Like if you want to see what the sound processor is doing, you can just click on the sound processor part of the synoptic, and it's going to take you right here. The sound processor is built in. This is all part of the digitally controlled, DSP controlled modulator. It includes the RDS encoder and the audio processor. So all of this is being done in the digital realm. It can be very accurate, very well controlled. The sound processor has, I think, up to 10 presets. It's got user control. Obviously, you can change any one of these presets that you want. You can share presets back and forth. You can import and export presets with friends who have Ecreso transmitters, and it's a pretty competent 5-band audio processor. It's very nice for a lot of the stations that we work with. If we look at the synoptic, we can also look at the what's going on with the player. This is the audio source that we're using at the moment. Again, going through the audio processor. There are some advanced measurements that you can see that will tell us things about the spectrum occupation. There's the MPX spectrum and your current audio levels and modulation. It's got a lot of features, like we said, built-in RDS encoder, which is useful. It's got a built-in audio transport system, an audio decoder, APT audio decoder. You can control, we were talking a little bit about security. So one of the things that the Ecreso transmitters have is network security, including the ability to restrict SNMP to the V3, the encrypted password protection version of SNMP if you were using SNMP management. And you can also do firewall settings. So you can control which interface, which port. You can whitelist certain IP addresses. So this plus your site firewall can really go a long way to helping make your transmitter secure. So very efficient. You can see what's going on every point of the transmitter. You can see what's happening. What's your input power? Click on the power supply. You've got all the information there. What are your fans doing? You've got all the information there. SD card. That's where the backup audio is stored. So the transmitter can accept, of course, analog audio, AES audio. It can accept MPX over AES. It can accept anything over IP. So let's go back to the PowerPoint here and move forward. So this is kind of the heart of it, and I should emphasize that this is not a digital transmitter, right? We aren't generating DAB like they do in Europe or HD IBOC like they do here in the US. This is a DSP. It's a digitally controlled modulator for an analog FM transmitter. And it's a neat package because you put audio into one end of this thing, whether it's MPX audio or digital audio, analog audio, and out the other end comes a full RF modulated FM signal. So it's all done in the digital realm. It's very high quality, very precise signal. One of the better sounding transmitters you're going to encounter anywhere in the world. The dynamic RDS built in, that again is part of the digital modulator. We talked about the APT IP decoder. APT MPX is a great way to transport your MPX signal over IP. We have compressions that can take the signal, the bit rate of that composite signal down to about 300 kilobits a second. We've got the always-on redundancy, SureStream redundancy capability built in. So all the capabilities of a full APT decoder, audio or MPX decoder, are built right into the AIO transmitter. So it's one less piece of hardware you need at the transmitter site. We looked at the 5-band processor with all the presets, no additional hardware, all the different stages of the processor there. Now, Smart FM is a technology we introduced to the market a few years ago. It is a way to save on your operating energy costs. And it can lower your your operating energy cost by up to 40%. And as we saw from the transmitter schematic, your operating energy costs are a big part of the whole overall cost of ownership of the transmitter, much more than the acquisition cost. So if you can lower those costs, that's a great thing. So we'll talk a little bit about it here. Start by a small caveat. If you think about using Smart FM in the US, there are two things you have to do. You've got to get an STA from the FCC. This is not a difficult thing. We can help you with the paperwork. We've done it for a few stations in the U.S. already, and then tell us what your thoughts are. The energy costs in the U.S. are so much lower than they are in other parts of the world that the financial savings, unless you're into a bigger transmitter like a 5 or 10 kilowatt, financial savings really don't look like a whole lot on a 600 watt transmitter here in the U.S. compared to a 600 watt transmitter in Germany. In Germany, in fact, one of our big customers is a company called Uplink, and they're running Smart FM on a whole bunch of transmitters. So for them, it's a publicity thing. They can say, "Hey, look, we're saving the environment," because broadcast is a pretty big energy user in the overall scheme of things. So Uplink, by using Smart FM, they can say, "Hey, we're reducing our emissions, reducing the CO2, reducing the energy needs." Smart FM works similarly to what they call modulation-dependent carrier level on AM. So we analyze the audio signal as it comes in. We determine an algorithm that we run through an algorithm determines how much we can actually reduce the output power of the transmitter without causing any audible artifacts in the listening area, and then we apply that algorithm. And it, as you can see, looking at the RF levels in real time, or the strip chart there, it varies the power frequently. In fact, I've got a video here. This is from one of our test stations here in the U.S., and you can see the power level changing rapidly several times. It actually changes several times a second, but the display can't keep up with all of it. So that's what it's doing to reduce the power at the points in the modulation where it thinks it can reduce the power without affecting the listening area. Also, when you buy a new Ecreso transmitter, you get a year of Kibio monitoring. Kibio is our network management system, NMS. This particular example would be in the cloud. You can use that free Kibio to monitor up to 25 pieces of Worldcast Systems equipment, and you can expand that to add other manufacturers and more equipment later on down the line if you like it. But Kibio is one of those six that can just inhale information, a lot of information from a lot of different places, and give you that one big picture where you can see immediately if something's wrong anywhere in your network and drill down and find out the cause. Trends in FM broadcasting. We're seeing a lot more distribution of the MPX to the transmitter site. Instead of just audio, they process it and create the full stereo MPX signal at the studios and send it out via IP. That is going, it means if you have more than one transmitter site, everybody can get the exact same processed signal so they can sound exactly the same. The MPX signal is a big bandwidth user. So if you're going to transmit the entire FM MPX signal on IP, you need a little more than 2 megabits a second, at least. So you can reduce that somewhat by cutting back on the parts of the MPX signal that you broadcast, or you can compress the MPX signal. So the APT MPX means that you can get that, as I mentioned, that full composite signal through as little as 300 kilobits a second. up to about 900 kilobits a second, at which point our algorithm actually samples and digitizes the entire composite signal. It doesn't do any disassembly or reassembly or anything like that. Low delay, it's resilient against packet loss. Very useful if you've got multi-frequency or single frequency networks. So a multi-frequency network would be where you have one or more transmitters in an area that are broadcasting the same program, but they're on different frequencies. Typically, you would use what's called the alternate frequency function in the RDS, and the receivers would switch from one signal to the other depending on which one is stronger in their particular area. So you've got to make sure that the audio is fairly well balanced in terms of loudness between those two transmitters and time aligned, but it's not, you don't have to be that exact about it. If you're talking about a single frequency network where you've got more than one transmitter covering an area on the same frequency with the same program, then you've really got to get precise with your signals. So we have several solutions for that. So again, multi-frequency audio modulation has to be time aligned, but doesn't cause interference because they're on different frequencies. Single frequency networks, yep, any place those two signals overlap, you could have some interference depending on which one is stronger. There we go. Get my forward and my backward right. Audio content synchronization for SFN networks has to be very precise. First off, you've got to make sure that all of the transmitters are on the same exact frequency. So the carriers have to be locked onto the same frequency. That's typically done with a GPS sync. And then you have to make sure that the audio content is synchronized as well. So you've got to compensate for the network latency. You've got to compensate for the time it takes for the signal to propagate from one transmitter and the other transmitter and meet in the overlap zone. So moving that modulation, the synchronization of that modulation, is a very critical part of making a single frequency network work. This is a good example of it. So you've got the main transmitter, much larger signal, the booster transmitter, the smaller signal on the right. You can see that curved red line. That's the equal delay line, and that's where the signal is going to be basically balanced between the two. And so the car receiver could be picking up either or both of those signals. And so you've got to make sure that the delay is precisely adjusted. So adjusting the delay of the audio coming out of the main or the booster site is going to move where that equal delay line is. And so the big secret about doing SFN is moving that equal delay line to where the people are. And if you have what they call a mush zone, where the signals are not too well synchronized, which would kind of be the green area around the red line, you want to make sure that those areas are happening where people are not. So it's SFNs. We have a lot of experience in them. They can be a fairly complicated subject to tackle, but we've definitely got the hardware to help you find the way. SynchroStream, that's the technology we use to synchronize the audio on the IP transport, and we can adjust that delay in between the codecs in steps of 125 nanoseconds. So that would move that zero delay line about 37 meters one direction or the other with each step of that codec delay. Remote monitoring, you've got to keep an eye on everything to make sure you're on air, improve the quality of the listener experience. You've got multiple layers. You've got to monitor the equipment. You've got to monitor the site, the whole environmental situation, and the network as well. So there are lots of different monitoring software products, network management software products that can help you with that, including our own Kibio. And that's the end of the slide deck. Brian, did you have anything else you wanted to add in at this point?
Not really, no.
All over but the shouting.
Outstanding job there, Tony.
Say what?
You did an outstanding job there.
Thank you. I appreciate that. You as well. So we're gonna hesitate here for just a second and see if maybe we might possibly have some questions from our viewers. Chantal?
Yeah, no questions right now.
Oh, okay. Well, I guess we explained everything perfectly. All right. That's all we have. Brian and I are available. Our companies are available to help you. If you have any questions, we can answer them. We can make something up. We can maybe point you in the direction of a resource that knows more than we do. And we're happy to help. I've been in broadcasting literally since about 1975. So it's in my blood, and I'm always happy to help somebody solve a problem and get on the air, especially if they're delivering some kind of unique content that wouldn't otherwise be found on the dial. So if there are no other questions or items on the agenda, I thank you all for your attendance and participation, and we hope to see you again for another Worldcast Systems BSW webinar sometime soon. See you at a trade show, and see you on the dial. Thanks.